So in this section, we're going to talk about list. A quick recap. So far, we have talked about strings, we have talked about some syntax, conditionals, and looping. So this gives us a good background to now cover a wide variety of problems. Okay, so you guys are familiar with syntax, writing some conditional logic, some looping, and you have the idea of one data structure. And this data structure forms the since this is a sequence and many of the other data structures are also sequence, this gives us a very good start to lists and tuples. Things would be very similar in here. There are generic operations that will work exactly the same, and then there are specific operation inside the lists class that we will be exploring later half of the today's class and maybe next class as we go along. All right, so what is a list? List is array, right? If you're familiar with arrays in C++, Java, lists are arrays. And they are internally implemented as C++ arrays as well. C++ array of pointers. We'll come to this point in a minute. All right, so lists are ordered collections, right? Or what we call sequences. That means the left to right order of objects in list is preserved. List, unlike the strings, are mutable. We are able to change items in a list in place. All right, and items can be of any type. They are not restricted to any particular type, and no restrictions on length. Let's go over all of these one by one. Okay, let's begin with some basic lists operations. All right. So first of all, lists are represented by square brackets. So that is an empty list. Okay, and in Python the class is list. So just like str and int we saw, you can create list using that list class. So that's an empty list. Now, if you want to create a list, you can put items in the list, like you can put item number 1, then some item number 2 with comma separated values. So let's create a list. Suppose the very first object in the list is Mars. The next object is 3.14. And the third object is, let's say, 1000. So this is okay in Python. Now you guys must be expecting this as well, that all these types are different and list is okay with it. Okay, so let's define this list as, let's just call it this. Okay, so this is a list, and if you print it, you will get the answer. Now that's one way of creating list. There are other ways of creating list. Suppose you want to initialize something, basically, let's say you have a small list and you want to initialize, let's say, a list of size 100. You can write something like this. That's a list of 100 elements. Every element is 0. You can essentially say none as well. And you can create a list of 100 none items. You can also pass an iterable to a list constructor, right? So you can say list and then pass something that is iterable. For example, Saturn. That's a string. When you do that, it automatically understands how to break this iterable into individual items and then create a list from that. Or as we saw in the previous class, if you have range of, let's say, 5 to 100 with the increments of, let's say, whatever, 5, and you can cast this into a list, then Python will force and generate a list out of this. So once again, an empty list, then a list with some items like this. Then you have this constructor where you can pass any iterable and that will generate list. And you can also generate this through some kind of a multiplication. You can say 100 multiplied by 5. There are more ways, and that we will cover when we cover some more advanced utilities. Okay? So these are the initial ways of how to create a list. I'll give you 30 seconds if you want to try this yourself. Let's look at some other operations inside the list. Since we looked at strings, many of the operations on list are now easy. So let's just first look at indexing real quick. Suppose you have a list like this. Okay. And okay, let's create a slightly bigger list. Suppose I'm going to write list is, actually, let's create the list using a concatenation. Okay, so let's first cover the indexing. So it works exactly same as the string. The first item of this list is Mars. Okay. The last item of this list, which can be done as -1, is 1000. Exactly like how it works in strings. And suppose this is the list. Let's take this list. The slicing works the similar way. You can write 1, 2, 4, and you will get the slice. So all of these operations are exactly same as strings. So there should not be any trouble. This one slight thing, for example, list here, this list when we looked at it. So this list, when we wrote L0, it gave us Mars. So if you want to get to the last element of this iterable, because there's another string within the list, if you want to get to the last element of that sequence, then we can also add one more index. So L0 returns Mars, and then we say, give me the -1 of that. So you can go any level deep as much as it's allowed. For example, you could have put a list within a list. You could have said L equals to this, comma, let's say Jupiter, comma, let's say Neptune. Now, if you do L of 0, the very first item of that list is the whole list itself. Now, if you want to look the very first item of this list, you can do this. And if you want to look, let's say, the last item of this, then you can do -1. Any questions on this? I'm going to give you maybe a minute. Try this out. So the length of this list, let's look at this list. The length of this list, this is the first item of that list. This is the second item, and this is the third item. And once again, the len built in, just like it worked for strings, it will work here as well. It gives you 3. So this list contains 3 items in it. The first one is a list, second one is a string, third one is a string.
Okay.
Is there a way to calculate the length of a
Mhm.
entity? Like for example, the first item of the list L is
So you can
a
do len
list
of
of
L0,
3 items.
Yeah.
right?
Got it. Then it will be yes.
Yeah, or you can
Okay.
do len of L
Okay.
minus 1, so that will give you the length of this item,
Got it. That's the
right?
answer. Thanks.
So that's the length. So length works just like this.
Question.
Yes.
The
So with this, let's go to our whiteboard and let's look at the first property here, mutability. So lists are mutable. Okay, so suppose you have this list and you want to say L of minus 1 should change to, instead of Neptune, it should become, let's say, Mars. Then the list allows that and the last element changes, right? So this list object is changing in place. There is no new list being returned here. Okay, if you try to do that with, let's say, some kind of a string, suppose you had a string this and you said s of minus 1 should become, let's say, a, that would be an error. The string do not a string does not allow that. So lists are mutable, they change in place. All right, I'm gonna mute you guys. All right, so list, yeah. So that's the first point to understand. Lists are mutable. Now, second thing is lists are ordered collections. So let's take this list back. They have a left to right order. So when I created this list, and now it's stored in the memory in this particular order. So it will not change over time. When I write L of 0, it will always be, this will be the very first item until I change it, until I delete it. That's a different thing. But by itself, lists are ordered collections. Okay. And if you're wondering what is not an ordered collection, there are certain data structures which are not ordered. That is, Python does not respect, in that case, the order in which you have inserted those elements. It can keep those elements in any order internally. Okay, and we'll talk about those structures later on. So that's the ordered collection part. Now, any type of data that you can see from the example, we are able to store any type. And the finally is this, I was saying that this is an array of pointers. So essentially in the implementation side, okay, this is not an important details for most of the people. From the implementation side, this list is equals to a C++ array of pointers. So when you create this list, essentially an array is created. Suppose your list items were Mars, then 1.23, and let's say 1000. So essentially this list was created in the memory where the references are pointing to these objects. When you say this, a string is created somewhere and this reference starts pointing there. Then 1.23 object gets created somewhere and this reference is pointing here. 1000, so this reference starts pointing there. That's how it's internally kept. That's the implementation detail. Uh, if you just want to work with Python, you don't have to worry about this. And let's talk about a similar data structure called tuple. Some people call it tuple. I call it tuple.
To answer, just a quick question.
Yes.
So you said the lists are mutable, but is there a way where we can add or delete from the list?
There is a, yes, you can add and delete from the list. So I will show you that. Don't
Okay,
worry.
sure.
Yeah. All of this is going to be covered shortly. So list and tuples. So I'm going to introduce another type just to get some perspective. It's very, very similar to what a list is, but it's way simpler because it is immutable. Okay. That changes everything. So the number of operations you can do on tuples become very small because they are immutable. And lists are mutable. Let's create a tuple. They are represented by round brackets. And you can put similar items here as well. So let's just say this is our tuple. So I'm going to create this. So this is your now tuple. And the list is something like this. Let's create actually a similar type of list. So I can show you the examples back to back. So this is list and this is the tuple. All right, so suppose you want to change the last element of this list by saying that this should be 5,000. That is a permitted operation and list changes in place. But if you try to do the similar thing on the tuple, you get an error that the tuple object does not support item assignment. So tuples are immutable. And since they are immutable, you cannot do a whole bunch of operations on them like add, delete, and all the things like sorting and those kind of things cannot be done on tuple.
Can I ask you a question?
Yes.
Why is it immutable? What's the purpose of this? Do you know?
Yes, there are some purposes to this. What will happen is, I'll try to explain this right now, but probably we'll cover this in more detail in functions. But list can be changed in place. So suppose you have a function which takes in some arguments, let's say x. Okay, and there is some list here, which is let's say 1, 2, 3, and 4, something like that. And you pass it into this function, and this function here is saying, let's say somewhere like x1 equals to 5,000. And then it does its work. Then this list here will change to this. This list, which was global outside the function, will change. So because it can be muted, it changes in place. So this will change it in place. So if you don't want that, right, if you don't want a function to, let's say, change it, then what you can do is instead you can cast this into a tuple and send that tuple over. In tuple, if somebody tries to do that, that will fail. Tuple will send an error that this item is not you cannot assign values in this item. So when you want to have that const type of behavior, you can cast your list to a tuple and then pass that tuple. In other language, there are variables called final or const that cannot be changed. So it kind of gives you that kind of behavior.
Okay, thank you.
So it's only to cover like a user mistakenly changing it kind of a thing, right? Otherwise,
Right.
more like a protection against.
Right.
So in real life, what would be those scenarios? Like
Once again, you're
as an
passing something
example.
to a function, which is a list, and you want to enforce that does not function is not changing the list. That's one situation. There might be other things that may come up. So since there are less number of functions, less number of utilities that can work on list tend to be easier. There are like not a whole lot of things that you need to carry with the list.
Uh,
All right, so let's look at some basic operations on list to begin with. Suppose you have list 1, which is something like let's say 1, 2, 3, and you have list 2, which is let's say something like let's say so just like the strings, I mean, you can do L1 multiplied by 10. That gives you a new list. Okay, it doesn't change the list in original place, but it returns a new list that you can assign to something. Okay, so just like string, the sequence is now repeating 10 times. So the list has become whatever the size was multiplied by 10. You can do L1 plus L2. That generates a new list in which both the lists have been appended. Right? And you cannot do something like this. You cannot say list plus a number, just like you could not do a string and a number. Basically, you cannot because there will be type error that the list and the integer are not compatible to be added. So list can be added to a list. Some basic stuff. The in membership works in list. So suppose you have this list and you want to say, is 5,000 in list? That is true. Or you can say, is 5,001 in list? That will be false. So simple in membership. Okay, and let's take looping. So let me create a program. Opening up Thorny. And let's save it as so suppose you have a list and let's carry the list from here, maybe this one. Now you can just write the list, write the loop exactly how you did in strings. Okay, you can just say for item in list, print item. So for each item in list, we are printing the item. Or we can say for each item in list, item multiplied by, let's say 10. And that is okay. See, look at this, all the types are different, but Python is able to handle all of these, and essentially the corresponding output is printed here. Simply you can write the loop, and you can write the loop the other way as well. So you can do for item in range of len of L. And you can just say print item. What will be the output of this? Can anybody tell me? The second loop.
Mark the three items.
The index.
The indexes, right? Because we are doing on the range. So len L is 3. So range is going to be 0, 1, 2. So there'll be 0, 1, 2. If you want to print the item there, then what do we do?
L of that item.
L of that
Item of 0.
Yes, perfect. So you just want to say L of that item. So you get the similar way you can just loop through the list. All right, so let's take a quick example. Okay, so suppose I want to define a function. Okay, I'm going to say define. Okay, let's just call this function symmetric. It's not truly symmetric, but let's just call it symmetric. I'm just going to call this end symmetric. Suppose it takes, let's say, some kind of an array as input. Let's call this array. Okay, and this function will return true if first and last element are same. Okay, so I want to call this n symmetric with, let's say, lists. Here, let's just take this list. So this should return false. Whereas if I write this with Mars, that should return true. Okay, if I take this, then you guys can take a shot at it. Okay, I'm going to paste this on Discord now. So suppose you have an array like this. Okay, just give me a second. Let's copy this. All right, suppose you have an array like this, and you come here, like this. So I want to see if the first and last element are same. Right, so this is the first element, this is the last element. The first element can be accessed using array of 0. The last element can be done by array of -1. If I do equals equals, that will return either a true or false, right? Pretty simple logic, one line logic. All you have to do is just to return array of 0 equals equals array of -1. And that will give you the answer. So they are exactly similar to strings once again. There is nothing special here. Okay, let's look in one more topic. First, quickly, nesting in list. So we have already taken one simple example, but suppose you can have a list which can contain, let's say, another list. You can have 1, 2, 3. Right. And this list can contain a tuple, which is, let's say, 4, 5, 6. And this list can contain, let's say, a string, which is, let's say, Sam. So you have nesting. You can have deeper level of nesting than this as well, right? Each of these items can further have list and tuples inside. So if I do L of 0, so first of all, what do you guys think is the length of this list?
3.
3, right? So the length of this list is 3 because there are 3 items. One is a list, another is a tuple, and third is a string. If I do L of 0, I get this. If I do L of 1, I get the tuple. So this nesting can go on any level. Let's just do this. Suppose you want to represent a 2-dimensional structure. Okay, so array is 1-dimensional. So you have, let's say, some quantities which are linearly arranged. 1, 2, 3. But if you want to have a 2-dimensional structure, you can have a list of a list. So you can have, this is the first item, then you can have second item as 4, 5, and 6. Then you can have third item as 7, 8, 9. And you can put all of this in a list. So essentially this becomes, these are all what we call rows. And these are columns. So you give this kind of a 2-dimensional structure. So let's just create one real quick. So suppose I have, I'm creating a 2-dimensional list. So multi-dimensional lists are also referred to as matrix. So I'm just calling it capital N, and let's go here. Let's just define this 4, 5, 6, and then 7, 8, and 9. So suppose we have this matrix. If I do, what is the first row? The first row is this. What is the second row? The second row would be 1. What is the third row? Third row is M of 2.
Right.
Right. What is the middle element of the second row? What is the middle element of the second row? Can anybody tell me?
5.
Wow.
No, but how would you compute that?
Oh,
One,
M.
one.
Yeah, M1 or 1 and 1. Right? So that will give you the answer. That's the middle element. So let's take this matrix here. Okay, and suppose I want to print the item of the first column. Okay, so suppose I want to write a program logic where I want to print the first item of the first column in each row. Okay, so output should be 1, 4, and 7. How can we write this loop to get the answer?
For element or for I of M.
So you can write for row
row,
in
yeah.
M, print
M of 0.
print M of 0. So that would be this, right? That's not the correct answer.
Oh, M00. Oh, wait.
Why is it showing 3 times?
Why? So let's look into this. Why is it showing 3 times? Why do you think
Yeah.
it's showing 3 times? When you say for row in M, it is how many rows
Oh.
are there first of all in this matrix?
3.
There's 1 row.
Have to use row.
1,
3.
Row.
2, and 3, right? There are 3
Oh.
items.
M
And
row.
you're saying for each of these iteration, print the 0th element of this matrix. So 1, 2, 3 is getting printed. Correct?
M row.
Sorry, could you say that again, please?
So let's just quickly.
Can you do like represent this matrix in a row? Yeah. Okay.
All right, let's just look into this again. 1, 2, 3. That's the first item of this list. There's a list. The second item of this list is 4, 5, and 6. The third item of this list is 7, 8, and 9. Okay. If I write for x in L, print x, what will be printed?
All items.
Right. So yeah, first
Every row. Yeah.
every row will be printed, right?
Yeah.
So every row will be printed. So each item here is a full row, right? And it becomes easy when you call it row.
This is
So-
line. This is line or row.
What is that?
This is called line or row. It
You can
become a
call it.
line in the
I mean, yeah, you can call it
matrix.
line.
It become a line. Yeah.
Okay, sure, you can
So
call it.
row is vertical and line is horizontal now.
So row is horizontal and columns are vertical, right?
Okay.
These are columns.
Row,
They are
okay,
vertical
that's good.
and rows are horizontal.
Okay.
Which prints the rows. I mean, if
So when you say for x in M and then print x, you get each. So how do you get the first element then?
row 0, row.
Perfect. Yes. Let's see. For row in M, print row of 0.
row of
Right? For
zero.
each row, print the first element.
Mhm. Okay.
Correct?
Yeah.
Who has questions about this?
So it's really very simplifying, and it's a good thing. I mean, very simplifying and straightforward.
Yes.
So when you say for x in or for item in, the item will be taken the role of the item. So
yes, exactly. So you
the
say
list.
for item in M. This is just a placeholder variable. You can call it whatever you want, and you can say
So if
print
it is
item,
yeah,
and then
if it
item
is
begins.
dealing, if we deal with the list, that means the item will be just a number. Now we're dealing with matrix or the
Yes.
matrix. Yeah. So the row we call the row.
Yeah. This is just
It
a
should be called
variable.
row. It should be called a row or any variable. Could be item or could be
So-
x or could be anything.
You can call it whatever you want to call. There's no compulsion on that. Usually in the programming problems, when you deal with 2D situations, if you have, let's say some people call, if you call it I, J, and then let's say later on you have more variables X and Y, it becomes very hard to keep track of this. To give it meaningful names, what I tend to do is I keep this as row, this as column. So it's very clear that what variable I'm dealing with.
So for using the for loop and saying for x in m, automatically it will go associate the item or the x or the row with the row.
Yes.
It's not going to the column.
Yeah. No, it's not going to go to the column because the first item of that matrix is this. So it's going to go to the first row. Okay. And this is just a placeholder. You can say for cat in m, print m. It doesn't matter. Just to be clear. Okay.
Question.
Yes.
If you wanted to print.
Let's go to the next topic of sorting. It's a very important one. Okay. And when we were dealing with strings, suppose this is the string and you have my name, let's say Himanshu, and then you say sorted of S, you get string is sorted automatically. Now take a list. And let's say the list is a list of names. So suppose this is Frodo. Okay, let's just say first one is Sam. The second one is Frodo. Third one is, let's say, Mary. And fourth one is, let's say, Pippin. So you keep this and then you write sorted of L. Then it works. Python will sort the list based on some criteria. It compared all these strings and it returned the answer based on what it considered to be ascending order. So capital F is smaller than capital M, smaller than capital, small f is less than small m, then small p and small s. So which is the kind of convention we also follow, right? So these are in alphabetical order. That's the usual order of sorting.
Okay.
Let's take another example. Suppose you have 1,502,999, something like this. You say sorted of L. This returns a sorted list. But sorted, as we saw in the case of string as well, returns a new list. Okay, so the original list is unsorted. There is another method that we will look in the coming class where list will be sorted in place as well. But sorted, essentially, this built-in sorted will create a new list. And let's take another example. Suppose you have L1, which has 1000, and then you have, let's say, Mars and 3.14. Now you say sorted on L1. You get an error back. And the error is a type error. That is, this type of operation is this type of an operator is not supported between a string and int. Right? So you can say 5 is greater than 4. That is okay. But you can't say 5 is greater than Sam. That's a problem. Right? So you get a similar type of an error. So the objects have to be of the same type. List has to have some way to compare the two items in order to sort. If those are not compatible, you're going to get an error. All right. Let's look at the help of sorted. There is a very powerful thing in sorted. Well, first, sorted function works on an iterable and it returns a new list containing all the items in the ascending order. And then you have these two things. Don't worry about these right now. Then you have this key equals to none and reverse equals to false. So Python is saying that there are two more arguments that you can pass. if you don't pass, then this is initialized to none and this is initialized to false. But you can change it, and you can change it to something. Okay, so a reverse flag can be passed to request the result in descending order. We will try that right now. And a custom key function can be supplied to customize the sort order. Okay, so there is this key which can point to a different function which can determine the criteria for sorting. Okay, now you will see how powerful it is. So first of all, descending order. So suppose you have this L and you say sorted of L. So this sorts the list in the ascending order. But if you write this and reversed equals to true, maybe it's reversed. Okay, yeah, it's reverse. Reverse equals to true, then it will sort the list and then it will reverse it. Or you can say it will give the list items in descending order rather than the ascending order. All right. I'm going to give you 1 minute. Okay, try this your own before we go to the custom sorting. All right, so let's look at custom sorting. Okay, for this, I'm going to use the IDE and create a new program. And this one is called, let's say, sorting.py. Suppose that we have a list of names. Okay, let's call this names. And the names are, these are weird names. Let's say the first name is this. The second name is this. The third name is this. And the fourth name is this. Right? And suppose I call sorted on these names. And let's print that. Let's just say result equals to this. And we just print result. We may use that variable later on. So when we run this, the answer is something like A, B, 1B, C, and DD. It's expected, right? The very first character is compared. And if you have an answer, then that if you can, without ambiguously, you can determine what is smaller than the other element, then you can put them in the sorted order. A is definitely smallest, then B, followed by C, followed by D. Now, if you add more elements, suppose I make this AB and I make this, like, let's just keep that. Say this, and let's just add some elements here. Suppose B like this, and maybe AB here. Then when you run this, you'll get a slightly different order, right? Because the very first element here, A, maps smaller than C, so add becomes the first one. Right, so that's the default sorting behavior, like how you would sort the names of any people. Now let's just revert it back and bring it back to the original program. Suppose I want to sort this on the basis of length. Okay, and not on the basis of the characters. So the default sorting behavior is that we sort based on the characters. Instead, we want to, let's say, sort based on the length of these strings. Then comes the key argument. Let's go back here and just quickly look at help of sorted. The key. So a custom key function can be supplied to customize the sort order. So you can tell Python to, I'm going to print it like this. Use a custom behavior to sort. And the custom behavior, for example, here I'm going to use is key equals to len. I'm going to explain this. So let's print both the outputs now. and notice what happens. The first one is based on default sorting behavior, and the second one is now based on the length. Okay, how does this work? This works like this. So you call sorted, and then you pass, let's say something, let's say numbers. You pass some kind of an array, and then you say key equals to names, and then you say, let's say key equals to len. And let's say you have some names which are whatever, A, B, C, and then D. Okay, so these are, let's say, strings like these. So essentially what happens is when Python sees that key is defined, that it's not none, here it's length, that means the default sorting behavior has to be on the table now, and we are going to pass all of these arguments, all of these items one by one to this length, this function here. And the output of this will be used for the sorting behavior. So first, this A is passed here, and the answer comes back as 4. Then this B is passed, and the answer comes back as 1. All right. Then the C is passed, and the answer comes back as 3. And finally, the last element is passed, which is D, and the answer comes back as 2. Now this is used for sorting. So the shortest is 1, so B is first. And the second is D. Then you have C, and then finally A. The requirement for this function, there is a special requirement for this function. And the requirement is that whatever this function is, key equals to func, whatever that is, it should take one argument. Okay, this function should take one argument. For example, len takes one argument, right? You can just pass len of s or something like that. So it should take one argument, and it should return a value, right? It cannot not return any value. It has to return something, and that something has to be comparable. So that's the requirement. This function should take one argument, do something, whatever it wants to do, that's okay. But then it should return something that is comparable. Now, len is a built-in, but this does not have to be built-in. All right, this can be a custom function as well. That is, we can define something which can take one argument and return a value, and based on that we can do the sorting. Then that works too. Right, so let's take an example. First of all, any questions in this explanation?
Yes.
Go ahead.
Okay, go ahead.
Let's develop a custom sorting function. Suppose that this is the names. Okay, and let's make it something like this. Suppose this is A, this is, let's say, BZ, and this is CX, and this is DY. Suppose it's like this. And let's just take this out for a second. Let's sort this. So note that how this is working is, it's working on the length. So BZ is the smallest, then DDY. And now notice something, that when the two strings came of the same length, the AAA came first, because that's the default sorting behavior. So once you cannot use the custom behavior, there is a key function return the same value, then you resorted to the default behavior. of sorting. Okay, but let's change this. Suppose we were to say sort these strings based on the last character. Okay, sort the strings based on based on last character of string. All right, suppose you have to do that. So now the sorted result, the first one should be A, the second one should be this, because X is the smallest, then this should be Y, and finally this should be Z. All right, if that is the case, then we can write a function. Okay, I'm going to write a custom function because there's no such built-in function like that. And this has to be a function. You cannot just write s of -1 or something like that. So I'm going to write a function. This is called last. This function takes one argument, like I mentioned in this. It has to take one argument. And the one argument is that it takes a string. And this function has to return something based on which the comparison can happen. So that element is the last element. So we're going to say return s of -1. Since this is just one line, you can also write it like this. Okay, suppose this is like this. Now we go to print again and we say sorted, and instead of key we say last. Sort based on the last. Okay, let's run this. Notice the output now. The sorting is happening based on the last character. So A is the last character, followed by X, followed by Y, followed by Z. So you can define a custom function. The function has to have one argument and it should return something. Like, for example, here it's returning a character back, and then those characters are being compared to do the sorting. Any questions in this?
But it doesn't sort them.
Okay, so it looks like, so you're correct. Your argument looks correct here. Okay. And I may be mistaken. But if the custom sorting behavior did not work, so then whatever was present first is put first.
Okay.
That's what it looks to be the case. And initially what I said probably was incorrect. Right? So keep that in mind.
So
sorry about
With a
that.
grain of salt.
Is it sorting based on the first character only?
It's the length.
Because that seems to be that seems to be the case, right?
It's going by the.
No, I mean,
so if you, let's say, if I take
yeah, the key is the length, right? But the last two characters are having the same length, so
yeah.
So
then
whichever
it's
is
just
first.
basically
So this came first because this
whichever
was
is
first in the list.
comparing.
This came first because it
Okay.
was first in the list. That's why this happened.
And if you want to add further logic to keep sorting this kind of race condition, or
Can you repeat your question again?
so if you want to add additional logic to sort the last two elements,
Yeah, you can do
Or-
that. You can basically whatever the custom function you're writing, how much ever complicated logic you want to put, you can put. But in the end, you have to return some value that can be used to sort. Right. So you can, based on the first two character, last two character, or middle characters, or something like that.
And you can return just one value, right? Or can
Yes.
you return more?
I mean, you can return any type of value that can be used as a sort of comparison. Right, so it can be string, number, floating point, that kind of thing.
I mean, so you could do a filter and only return one value or two values, right? If that's your custom function.
Sure. Okay, we are severely over time. Let me quickly show you the assignments. Okay, I'm sorry about that. Let me show you the assignment. And the assignment is, we have time now. Okay, so it's Wednesday. We have time till Monday. in the repository, I have added a list directory. The list directory has 3 problems in it. Okay. The first one is called match words. The second one is called front tags. And the third one is called sort last. Once again, this is taken from the Google Python class. You can read the description and attempt these problems. This last one is a list of tuples. So I think you should be fairly comfortable with it. There should not be any problem in understanding this, that this is a list of tuples. And if you have any question, you can always talk to me on Discord. I will help you. So this is the part 1, and the part 2 is once again to the coding bat Python list 1. And I'm going to put this on the GitHub so it's easy to find these 2 things. So all of these exercises, there are 12 problems, should not be very hard. Okay. I'll actually go through these problems to make sure that there's no funky logic anywhere. So this and the list1.py. Any questions?